the second one on number 20, rational or irrational? Rational, because the square root of 4 is a perfect square, right? Number 3 on number 20, rational or irrational? Irrational, because the square root of 2 is not a perfect square. What about number 4? Rational, and it's the weirdest one on here because it has the square root of a fraction. But is 4 and 9, are they both perfect squares? Yes. So when you take the square root of 4/9, it's actually 2/3. And remember, it can be written as a fraction. Okay, so let's type it into Desmos. So I've already typed in the third one into Desmos because I wanted to show you what an irrational one looks like. So 5 plus 2 square roots of 2. Do you see how the decimal stops, but it goes as far as it'll let a decimal go on Desmos? So even though it looks like it stops on here, I want you to know that it really doesn't. The calculator can only hold 9 to 10 digits, so that's why it looks like it stops, but it continues going on. So when you have one that is that long, what you have to go back and ask yourself are the square roots that are in it perfect squares? So let's type in that third one. We got to do the square root of 4 divided by 9. And then we've got to add 7. Thank you. Plus 7. And see how it's 7.6. Now I could see where you might have got tricked up here. How it's got a 7 at the end? That's because there's a 6 behind it, so it had to round up. So technically, this is a repeating decimal, right? And didn't I say that it could be a repeating decimal to still be rational? Because 0.6 repeating is actually 2/3. So that's why this one is rational. Is everybody okay with that? What question do you have about Ashley?
I don't know.
When you look at it on the calculator right here, do you see that it's supposed to be 0.6 repeating?
Yeah.
Okay, so if it's a repeating decimal and you look up there in that paragraph that I typed up, it says decimals that terminate or repeat. So since this is a repeating decimal, then it is actually rational. And then when I look at the last one, it's a decimal plus a decimal that stops. So what does the answer have to be for that last one? Rational. So on the adding part, any questions about any of those? Please just keep in mind, you're looking for the ones that don't have perfect squares or the square root. That's irrational. When I get down here to 21, I want you to know how to do these without a calculator, but you get the calculator, so why not use it? But when you multiply them, if the perfect squares go away, and it's like you take the square root and then it gives you a number. So I want to show you the first part by hand, and then the rest of them we're going to use the calculator. So square root 2 times 3 square roots of 8. If you had to do that by hand and simplify it like we did on the test, you would multiply 2 times 8 because we multiply by what's under the square root. So what is 2 times 8? 16, and then 1 times 3 is 3. Is square root of 16 a perfect square? Yes, square root of 16 is 4. So this really becomes 3 times 4, which is 12. So is 12 rational or irrational? Rational. Now, if you type that into Desmos, guess what answer it will tell you? 12. And as long as you know 12 is rational, you're good. All right, the next one, what is it? Irrational. Now, just to show you by hand, you'd multiply the numbers out front. 3 times 5 is 15, and 2 times 3 is 6. Is the square root of 6 a perfect square? No, that's why it's irrational. This is a terminating decimal times a terminating decimal, so our answer is also going to be a terminating decimal, which is rational. And then the last one, square root of 3 times 7, still has a square root of a not perfect square, so the answer is irrational. Any questions there? All right, we are almost done for the day. If you'll hang in for a few minutes, we're going to skip to number 26. There's something I need to add in the instructions on number 26. It says, consider the function f shown. Identify the intervals on which the function appears to be decreasing, and here's what they left off in the directions. Select all that apply. What does select all that apply change about the problem? You can have more than one answer. And guess what? There's more than one answer here, or I wouldn't be telling you to add that. Typically, with this program that I used to get this problem from, if there are 4 answer choices, it's just a multiple choice. If there's more than 4, it's a select all that apply. So I think they assume that you know that, but it didn't put it here. So what does increasing mean on a graph? Going up from left to right. So if I'm looking at the graph from left to right, where is it going up? And these are going by the x values. So let's start with the answer choices. The answer choice says x is less than -1. So here's -1 right here, and less than would be to the left of that. So this part of the graph right here, is that part of the graph going up, or is that part of the graph going down when I look from left to right? Down. So that's decreasing. Did the question ask for decreasing or increasing? Decreasing. So I can select A. Now looking at B, it says less than 0. So I'm going to erase my pencil line I just drew here. And less than 0 is right here. So when I go from less than 0, it's going down, but then what happens? It starts going up. So is it decreasing the whole time less than 0? No, it's decreasing some, but it's also increasing some. So part B, I can mark out. What I want you to do is I want you to look at C, D, and E and see which of the other ones you think we should circle.
What does C mean?
Between -1 and +1. Try C, D, and E. All right, looking here from -1 to +1 is this part that I just highlighted. Is that part that I just highlighted from left to right going up or going down? Up. So that would be increasing, and they ask us for decreasing. So I'd mark out C. Then it says greater than 0. Well, here's 0. That means everything to the right of 0. For part of to the right, it's going up, and then what happens? Going down. So we can't pick D either because it has to be decreasing the entire time. Then I look at E, x greater than 1. Well, here's 1. When I go greater, that's to the right. Everything to the right of 1, is it going up, down, or both? Down. So E is also part of our answer. Questions about that? Looking at number 27, when I look at A, without even reading the question, what do those symbols in A mean? Infinity. So A means from -infinity to +infinity. We sometimes call that all real numbers. So I want you to know that if it looks like this, -infinity to +infinity, that also means all real numbers. Okay? So the question says, on what intervals is the function increasing? So looking at this graph right here, I want you to look at those answer choices and see which one is where this graph is increasing. When I look at the picture, where's this graph increasing? Nowhere. It's decreasing the entire time, right? So which one of those answers represents nowhere? Never. If it changed and the question was exactly the same, but it said over what intervals is the function decreasing, which answer choice would I select? A, because isn't it always decreasing? It's always going down. So A is what we pick if it had said decreasing, because it is always going down. All right, let me tell you what numbers you have for homework tonight. Numbers 22 through 25. and 28. So 5 problems, numbers 22 through 25 and 28. You don't want to do 22 and 25 without Desmos. All you got to do is type it into Desmos to get the answer on 22 through 25. So don't be too lazy to do that. It'll take you like 3 minutes. I don't care if you do it through lunch today while you're waiting on the ladies to bring you your lunch. But just do it before you get back in my class tomorrow. For those of you who are wanting some extra